Okay, in this video we're going to talk about the nomenclature of amines. Let me apologize ahead of time if you hear a whooshing sound. I'm recording this in the lab, and so that's the fume hoods that you're hearing. There are two IUPAC methods for naming primary amines. This first one works best for simple amines. And what we do is we just name the alkyl group that is attached to the amine. So we would call this ethylamine, this would be isopropylamine, this would be cyclohexylamine. But I will say this method really only works well for simple amines, so it's good to be aware of this method because lots of people will use it, but when you're studying for the tests and the quizzes, I think it's easier to focus on the second method because it's going to be more able to be universally applied. Alright, so the second way of naming primary amines works just like alcohols, except instead of using the suffix OL that we would use for alcohols, we use the suffix amine. So if I was going to name this compound, I'd locate the longest chain, I'd identify the different substituents, so I've got two methyl groups, and I have the amine, identify which one has the highest priority. In this case, it's the amine, and I'll talk in a minute about how the priority of amines fits in with the other functional groups that we've looked at, but it has a higher priority than the alkyl groups, and so if we were to go through and determine the stereochemistry, we would see that both of these chiral centers are R, and so this would be 2R, 4R, 4,6-dimethyl, and then we give the position of the amine just like we would in alcohol, and so this is 2-heptanamine. Okay, so where do amines fit among the priorities of the other functional groups? Well, relatively low. So they're higher than the alkenes and the alkynes, but compared to all the other functional groups that we've learned, they come in the lowest. And so even alcohols have higher priority than the amines. So what do we do if there's a group present that has a higher priority of an amine? How do we name it as a substituent? Well, we use the prefix amino. Okay, so here are some examples when the amine doesn't get priority. In this case, I have a 4-carbon chain. It has an alcohol and an amine. The alcohol has higher priority. And actually, I just noticed that this name is actually incorrect. So we would use amino to indicate the presence of the amine, and it is on position 4, but what we haven't done here is they haven't told us the position of the alcohol. There's nothing that says the alcohol has to be on carbon 1. It very easily could have been on carbon 2 in this case. So really, the name of this first one should be 4-amino 1-butanol. Here's a second example. We have an amine and a carboxylic acid. Carboxylic acid is among the highest priorities, and so it gets precedence over the amine. And so as our base, we would use benzoic acid. The amine is para to the benzoic acid, and so we would have para-amino-benzoic acid. Now, if we have a benzene derivative and the amine does have the highest priority, then the parent name is going to be aniline. So the amine has a higher priority than the chloro group, so this would be meta-chloroaniline. Or the amine has higher priority than a fluorine or an alkyl group. So this would be 5-ethyl 2-fluoroaniline. Okay, if we have secondary and tertiary amines, the naming is similar, but there are a couple caveats. In the simple method, it really does work like it did with the primary amines. We just name all the alkyl groups that are attached to the nitrogen, and we put them in alphabetical order. So this one has an ethyl, a methyl, and a propyl. So EMP, this would be ethyl-methyl-propylamine. If we have multiples of the same substituent, then we would use the prefixes di or tri. So this would be diethylamine, or this would be trimethylamine. Okay, when we have more complicated secondary and tertiary amines, we're going to base it off the second method that we learned for naming primary amines. So if I forget about the fact that I have other substituents on the nitrogen, what I would do is I would find what the parent chain is, so find the longest carbon chain. In this case, it would be the 6 atoms, right? And so if this was an alcohol, this would be 3-hexanol, but because it's an amine, it's 3-hexanamine. What we do with the groups coming off the nitrogen is we treat them just like they were substituents coming off the main carbon chain, except in this case, for the locant, we give them N, right? So they're not on one of the numbered carbons on the carbon chain, they're coming off the nitrogen, so the position is going to be N. So these chlorines would be 2-chloro, this methyl is N-methyl, or this methyl is N-ethyl. We put them in alphabetical order, just like we would anything else. And so then the name of this compound, if we did the stereochemistry, we would see that this chiral center is S. So the chloros, C, comes before the ethyl, which comes before the methyl. So this would be S, 2,2-dichloro, N-ethyl, N-methyl, 3-hexanamine. Okay, so I want to finish up this video with a couple of examples. So we want to give the IUPAC name for this compound. And so I notice my highest priority functional group is the amine. So I need to find the longest carbon chain that contains the amine. And so I think that's going to be 1, 2, 3, 4, 5, 6, 7. And I want the highest priority functional group to get the lowest number possible. So I want to start numbering from this end. So I'll have 1, 2, 3, 4, 5, 6, 7. So the substituents that I have a 6-methyl here, and then this methyl is coming off the nitrogen, so its position is going to be N. So that's going to be an N-methyl. So my base name is going to be 3-heptanamine, and then I've got 2 methyls, so it's going to need to be a dimethyl. And so we give the letters before the numbers, so it's going to be N6 dimethyl 3 heptanamine. And I guess I didn't need the parentheses around the N and the 6, so let's get rid of those. But I do need parentheses around the configuration. So we need to assign the configuration here of the chiral center, right? So I'm looking at this chiral center. The highest priority is going to be the nitrogen. Then this will be the next highest priority. This will be 3. The hydrogen's in the back. So 1, 2, 3, I'm going counterclockwise. And so this is going to be S, N6 dimethyl 3-heptanamine. Okay, one more example. In this case, the carboxylic acid is going to be the highest priority functional group. And so we're going to have to name the amine as a substituent. So I want to start numbering from this end, so the carboxylic acid gets the lowest number possible. This is like a pretty simple straight chain. So I have 1, 2, 3, 4, 5, 6. So I have a 4 amino, a 3,3 difluoro. So when I put those functional groups in order, I'm going to have 4 amino, 3,3 difluoro, and then no number for the carboxylic acid. It's understood to be at position 1, and so then it's going to be hexanoic acid. And then again, to finish it off, I need to assign the configuration of that chiral center. So, right, I'm looking at nitrogen versus carbon versus carbon. So the nitrogen gets the first priority. This carbon has fluorines coming off it, so it's going to be 2. That's going to be 3. So it looks counterclockwise, but because the highest priority group is in the back, I need to switch it with the nitrogen that's on the wedge. So it's going to be the opposite. So it looks like it's S, but it's in fact R. So I have R 4-amino 3,3-difluorohexanoic acid.